Hey JCam fam, we are back introducing states of matter. We're going to go through a little bit about what each one looks like and most importantly how they all relate to each other when we go through phase changes. So let's get to it. Alright, there are three states of matter that we focus on in chemistry, though there is a fourth. You've probably learned it before. It's solid, liquid, and gas. Let's look at each one individually to make sure we can describe their properties specifically. So a solid, as we know, is anything that we can touch but we can't go through. So for a solid, we know it has a particular shape to it. That's pretty common sense, right? It has a definite volume, meaning it does take up space, and the space that it takes up pretty much stays the same. Think of something like your desk or a ring or anything, a cup in your hand. It has a volume and a shape to it, and it's not really changing unless some kind of impact happens to it. It also has high density, meaning that the particles are really close together, which is why we can't just pass through it with our hand or walk through it or anything like that. The important thing too is to remember that all matter has energy, kinetic energy, and since it is a solid, it still is going to be moving, but since it's a solid and stuck in its particular shape, it's going to vibrate in place. So the individual atoms will actually shake and vibrate, but we can't tell because it's on such a microscopic level. So solid is the first of the three phases we'll learn about. But again, solids tend to have the lowest energy because they have the least amount of movement, so the lowest amount of kinetic energy. Moving to liquids. Liquids is something that you obviously are still familiar with as well. Think of a gallon of milk. It's not going to hold a specific shape unless it's in a container. So that gallon of milk is going to be in the shape of the milk jug. But if you spill it all out on the floor, it'll still be a gallon's worth of milk, which means it still has a specific set volume to it, but it will take a different shape. It'll take the shape of the floor. So compared to gases, which are very spread out, liquids are still considered to have high density, but tend to have less density than a solid. So that's why if you ever put a solid object and its liquid form together, it tends to be that the solid sinks. Now, there's only one specific example of that where that normally doesn't hold true, and that's ice. For some strange reason, water freezes and becomes less dense as a solid than a liquid, which is very important. We'll talk about it later in the year. But if ice didn't actually float, this world would look very different. We'd be in a constant ice age, and maybe even evolution would have never taken place for humans to be around. But anyways, going back to liquids, the shape of the liquid is determined by its actual container. And again, just like solids, those particles are going to vibrate in place. So they do have kinetic energy, they shake and vibrate, but we just can't tell that from the naked eye. But they do have their kinetic energy. And again, the fact that these objects are close together allows them to flow past each other, which is why liquids can pour. And finally, probably the one we know least about because we don't notice gases as much, but gas is the third phase in states of matter, and it does not hold any shape whatsoever unless it's in a container. The interesting about gas as well is that it will fill up its entire container, so it doesn't have a definite volume. So if I spray cologne in the corner of a room, obviously after a few minutes you can start to smell the cologne at the other end of the room. That's something called diffusion, but what happens is gases naturally spread out and fill the volume of its container. So they are considered very low density because they're so spread out, so they're not packed in there together. So solids and liquids always have more density than the gases itself. Right? And also with kinetic energy, gases tend to have the highest kinetic energy because they have constant random motion, bouncing around, creating pressure in a system or in their container. Now, since we've talked about the three phases, let's talk about how all three phases can flow from one to the other. So this is called a heating curve or a phase diagram. And as you go up in the curve, you'll notice that your kinetic energy and your temperature rise. And as you go over, your heat energy increases as well. But to read it, let's start and look at the three phases that are on here. First of all, in this area, to begin with, at the cooler temperatures and less energy, you have solids. Then, as you heat up a little more, you get to the liquids, which have a little higher energy. And then you get to the highest energy phase, which is the gas phase. Of course, the plasma, fourth one, is also a higher energy, but we're not getting into that yet in this class. But the phase changes are ones that you've heard of before. When you go from a solid to a liquid, we call that melting. But when you go from a liquid and freeze back to a solid, we call that freezing. All right? Also, when you go from a liquid to a gas, we call that boiling. But maybe you don't realize or you haven't run into this one before, but you've experienced it. But to go from a gas back to a liquid is called condense or condensing. You've experienced condensing probably if you've ever parked your car outside and it was a cool evening, and in the morning you had actual like dewdrops that formed on your car's windshield, or that was the water vapor in the air hit your cooler car, the glass on your window or that, and the water vapor actually condensed back down onto the windshield. So went from a gas to a liquid. All right. Notice though with your temperature that at both phase changes, melting point and boiling point, when you are converting back and forth either from liquid to solid or solid to liquid or liquid to gas or gas back to liquid, that the temperature stays constant during those phase changes. And in our heating curve that we do in chemistry, we hope to see the same thing as well. It will be important for you to know the names of the phase changes. So, when we look at water specifically, solid water we call ice, liquid water we call water, and gaseous water we call water vapor. So, if you're going from ice to water, it's melting. From water to water vapor, it's boiling. But don't forget to go back. From water vapor to water is condensing, and from water to solid ice is freezing. There are other phase changes where you jump. You skip the liquid phase and go right from the solid phase to the gaseous phase. That's called sublimation. Sublimation happens, maybe you've seen it with like air fresheners or mothballs, where they're there and then all of a sudden over time they just disappear. They don't melt, form a puddle, but they're solid and then all of a sudden they're gone. They sublimate. They turn straight from a solid to a gas. And if you ever go from a gas back to solid, that's called deposition. All right, deposition we don't see too often, but if you take a very, very, very cold winter day, negative 20 wind chills, and you take a pot of hot boiling water and throw it up into the air outside, by the time that water hits the ground, that gas, that water vapor, turns to ice or snow. So it went from a water vapor all the way to a solid instantly, and that's called deposition. So phase changes do give off or take in heat energy, and it's important for us to know that. So endothermic, and you may have heard of endo and exoskeleton from biology, but endothermic means that energy or heat is taken in by the system. All right, so whenever we're moving uphill in our heating curve, that process is called endothermic. And the reason for it is you have to add heat to the system in order for it to go from a solid to a liquid or from a liquid to a gas. So that's always an endothermic process whenever we're melting or boiling something. Now, exothermic means that you have to give off heat. So the way I like to think of it is giving off heat is like losing heat. And to go from gas to liquid, you have to get rid of some heat energy in order to calm down so the water vapor can turn to water liquid. Now, it also is exothermic. You have to give off or get rid of energy in order to go from liquid to solid. So whenever you're moving downhill, you are exothermic on the heating curve. And again, whenever you're moving uphill, you are endothermic, meaning you have to put heat into the system. All right. So again, quiz yourself. Make sure you know the difference between melting and freezing, which I think you do, but melting is endothermic. We have to take in energy in order to make it happen. And to boil means an endothermic process as well. Now, to go the opposite way, again, freezing, you are losing energy, so you have to get rid of it or give it off. So that is an exothermic process. And of course, condensing as well is an exothermic process, because in order for water vapor to turn back to water, you need to condense, meaning you have to get rid of extra energy, heat energy, in order to calm down. All right, so we went over the three-phase changes, and then we went over a heating curve as well, and which ones are endothermic and which processes are exothermic. It would be wise to know the names of all of them, which are endo, which are exo, and of course, what a solid, liquid, and gas are by definition, and how they relate to each other, and how they are different when it comes to kinetic energy, their shape, and their volume. Have a great day, JChem fam. Thanks for listening.